Well, thank you very much for inviting me, and you all for being here. And I will say, when I say I cover everything at NPR, I should be careful to say everything in science, environment, and medicine over the years. So I'm not an expert on the world of Washington politics, although I have a ringside seat to it. So I'd be happy to try to grapple with some of those questions about how this does play in Washington as we go along. Let me keep a look on time here. That's not my phone. So at any rate, I actually want to start from an early time in my career. This is a picture of Henrietta Lacks, who in 1951 had her cervical cancer cells harvested and became the first immortal cell line. And I encountered this story in the early 1980s when I was a newspaper reporter in the San Francisco Bay Area. There was a rather compelling study that had come out showing that a huge number of these cells, these HeLa cells, were just laboratory contaminants. People thought they were studying one kind of cell, but actually they were studying HeLa cells. And this had been a problem that had been known through the 1970s, really, growing concern about this. And this was just a staggering study when it came out in news reports. And I thought, wow, so, something like half, I don't remember the exact numbers, but a large percentage of cell-based research was based on a misunderstanding of what cells they were studying. And I thought, wow, this is such a huge problem. What is the scientific community going to do? Are they going to retract all these papers? Are they going to develop new methods to take care of this problem? I mean, this struck me as like, wow, this is such a huge blow to science. And the next day there was nothing, and the next day there was nothing. And this story just disappeared without a trace. Not just the story, the idea, as far as I can tell, there was no response at all from the scientific community to this revelation. Michael Gold, a science reporter, came back to this in 1986 and wrote a whole book about it, including a sort of narrative of this kind of irascible and unfortunately kind of unpopular guy named Walter Nelson Rees, who was pushing this idea and trying to get his colleagues to pay attention to cell authentication and cell contamination. And again, this book came out, it was really well told. The real problem was the messenger was not Michael Gold, but the scientist himself was a real curmudgeon and was not, and was dismissed by his peers just because he was right, but he was so obnoxious about it. I think that did not help his cause at all. So this, so again, this story came up, people talked about it, and it disappeared without a trace. And how big a deal did this make? Well, this has been a problem through the ages, and finally, these guys last year did a paper asking the question, how much of this is actually contaminating the scientific literature today? Remember, we've known about this since the 1970s. Scientists have had very good tools since probably the 2000s to quickly and easily validate their cell lines. And what's happening? And their answer was, after all of these years, they found 33,000 articles citing wrong cell lines. They were HeLa, but they were actually dealing with HeLa, but they were publishing as though it were some other kind of cell, not a cervical cancer cell at all. And another 500,000 citations of those papers. So as a journalist, my question is, and one other point, this is one of 400, well, there are 400 misidentified cell lines out there. HeLa is responsible for about 120 or 130 of them, but there's tons of other examples of this throughout the biomedical literature. The International Cell Line Authentication Committee, a group of volunteers got themselves together just to try to quantify this problem and put this issue on the map. So why am I starting off with this story? Well, it's my job as a scientist to ask, or science reporter, to ask some very basic questions about, why is this going on? This is largely funded by taxpayer resources, right? Why should taxpayers be putting up with this? And isn't it my job as a journalist to say, attention, please, you're wasting our money if you're not paying attention to the identity of your cell lines. So it's so this is the watchdog role of a science journalist. And as Steve noted, many science journalists focus on the interesting, the exciting, the stories that drew many of us into science reporting, which is, it's interesting. It's you guys are exploring the frontiers of science, and we want to understand what's on those frontiers. But we also have a role as watchdogs to say, if there's something that is going wrong, that you're misspending essentially our taxpayer dollars, we have a right to speak up and talk about that. This paper, I think, is another important milestone along the way. This is Glenn Begley and Lee Ellis published this paper a couple years ago, and they tried to replicate 53 key studies in cancer research. Begley was head of cancer research at Amgen, and he wanted to know whether these publications that were coming out of universities, if he could replicate them, and if so, he could develop drugs out of this. This is a fairly well-known paper by now. And they were only able to validate 6 of them reproduce. And this wasn't just a one-off attempt to reproduce. They actually took it back to the original scientists in many cases and said, hey, we're having trouble reproducing this. Would you run it again, and would you see if this works? And in many cases, Begley's a little vague about exactly how many cases, et cetera, but in many cases, the original scientists couldn't reproduce it. And they said, oh, we're just having a bad day today or whatever. Begley did notice that the one condition that they applied was, this time we're going to ask you to blind the experiments if you didn't do it before. And that may have had something to do with why they couldn't actually get the same results. But at any rate, this matters. This has to do with the flow of ideas from university labs into drug development and into things that will benefit us. I mean, let's remember why we're supporting biomedical research as taxpayers. We're doing it not to make sure that university scientists have nice, long, comfortable careers, although that's a nice side benefit of this. We're doing this because at least Congress believes that a lot of this research is being done to improve human health around the country, around the world. And so if that's not happening, that's a major failure. And looking at the money here, we can see, I usually show this slide to talk about the fact that funding doubled for the NIH between 1998 and 2003 in spendable dollars, and then to have this gradual 20% decline in the following decade. And that created all sorts of problems in getting the incentives that were already not terribly good, even worse in the world of biomedicine. But I mean, the point is, I'm showing the slide now because we spend a lot of money on this research, and we want a return for our investment. And it's not just sort of these, gee, it would be nice to understand better how cilia work. We want to know how cilia affect disease processes, and how we can come up with new treatments and drugs and so on. So these are serious issues that, if I'm sounding defensive, maybe I am, but there are reasons for this, why we care. This is another slide that I show often. This is called Eroom's law, dubbed by the guys who drew this curve. Eroom's law is Moore's law spelled backwards, and this is how much it costs to develop a new drug. And as you can see, this is a logarithmic plot, and it shows that it costs more and more money to produce fewer and fewer drugs. And this is not driven by the reproducibility problems, I don't believe, and the guys who drew the graph do not believe this. But the point is that if we're getting less productivity out of original research than we should be, this is not helping deflect this curve. If we could improve the efficiency of research, the dollars that go into it, then we could bend this curve at least a little bit. There are obviously many other factors involved in why Eroom's law exists. But this is, again, why we care. I just want to put a face on this. This is Tom Murphy, who had ALS and was diagnosed with it. He registered for a clinical trial, one of many, many clinical trials for ALS that failed. So just to remember that people are dying waiting for progress in these fields. And as a journalist, I have to think about that as well. It's not simply my job to think about the health of the scientific enterprise and the ongoing support of science, which is I personally believe that obviously that science is good and should be supported, but I do have a responsibility as a watch person as well, as a watchdog, I guess is the word. So anyway, out came my book, which is, I must say that this was not my title for the book. Actually, my title was actually Science Friction, which was the title of this, because I wanted to convey the idea that science is not stopped, that these problems have not stopped science, but it's creating friction in the system, and then if we can think smartly about things we can do to fix the system, we'll get more bang for our buck, and that's great. We're always going to have ideas that, experiments that fail or experiments that don't lead where you expect them to. And that's all well and good as long as they're well designed, well thought out, and as long as you aren't, using crazy HeLa cell lines when you think you're studying liver cancer. I mean, there's some really basic things that can be and do need to be attended to. I was a little nervous about this title. It was published. We went to bed in the summer of 2016 before the election results were in, and I thought, well, the Clinton administration will be able to handle this. It's not a big deal, But then a lot of people started asking me about this book and about this train of thought and whether this is a danger to science. And I think Steve has articulated some of the many reasons why this is not simply people looking for thoughtful, great evidence to persecute their ideas about how they want to spend their money. It's, honestly, they talked about cutting the NIH budget by nearly 30% and the National Science Foundation budget by 30%, the Trump administration did. And why did they do that? It wasn't because they're saying, because science is broken. It's like, no, we want to balance the budget. We want to have a big boost to Pentagon spending. It was, these kinds of arguments don't get lost in the weeds at all. In fact, the weeds tend to get ignored along the lines. But people do ask about this. And my answer usually is that a lot of what I describe in the book is looking at the pressures that result from this hyper-competitiveness in science as a result of the fact that there are far too many scientists fighting for far too many research dollars. And if your answer is to turn down the tap on research spending, all you're doing is making the problem worse. So that's true, but I also don't, I've never seen the conversation get even anywhere near that kind of a discussion. These are happening at much broad brushstroke kinds of arguments, and it's not really about, science is broken, let's shut down the enterprise. That's just not a narrative that I'm seeing in Washington at all. And I want to give some credit to Francis Collins, who actually made a decision when these issues started bubbling up that he wasn't going to say, this is nothing to see, let's just move along and not worry about it. He went to Capitol Hill, he testified on Capitol Hill and said, yes, senators, I agree, this is a problem, and the NIH is addressing this. And he wrote this with his chief deputy a couple of years ago in Nature. In the long run, they say, science is self-correcting, we all know that quote, but in the shorter term, the checks and balances that once ensured scientific fidelity have been hobbled. I think it's excellent that he stood up to say, this is a problem, and we have some solutions that we're thinking about. Likewise, his not quite counterpart at the Food and Drug Administration, Janet Woodcock, who is in charge of drug approval for the FDA, was talking to me about how frustrated she is when she sees academics studies that come in support of drug applications, new drug applications, and she says, most of the time I just can't, I can't believe that I can't approve these drugs. She says, most of the time they're just not well-defined and well-done studies. And the quote you can see is, it's like 9 out of 10 airplanes we designed fell out of the sky, or 9 out of 10 bridges we built failed to stand up. We need rigorous science we can rely on. So I think even in the midst of a climate of real uncertainty and so on, in Washington, D.C., and around the world for that matter, it's important for people to still stand up and say, yes, we have problems. We're not going to pretend they're not here. We have to pay attention to them, bureaucrats and journalists alike. Just a couple of more things. The reproducibility crisis, just wanted to touch on this. I actually don't think it's a crisis, but this was a survey that Nature did, apparently not very scientifically. I got my finger shaken for using this slide and say, you didn't mention that it was not a very well scientifically designed study. But at any rate, 52% said there's a significant crisis, 38% said there's a slight crisis. I love that, slight crisis. Yes, we're having a slight crisis. And the remaining 10% said, I'm washing my hair, would you call me back? But at any rate, the point is this is not just a narrative made up by the news media. This is something that a lot of people are feeling and talking about. I actually don't think it's a crisis because I think, as Steve pointed out, a lot of these issues have been bubbling along for a very long time. There's always been, methodological issues that need help in science. I think what's happening now is there's an awakening. I think it's actually a good moment in science because people are realizing, there's some things we can do, some concrete things we can do to improve the matter and to make things work better. And I think that's great. I think that, part of a chorus that's talking about that by now, with both within science and outside of science to a certain degree. But I think it's important to get that idea across that, yes, here's some problems, let's find fixes. So a lot of my conversation and discussions, both in the book and when I talk to groups, is not just to talk about what's wrong, but to focus on people who do things right. And Arturo Casadevall is at Johns Hopkins. He has decided that what really needs to happen is improve training in medical science, particularly improving the way preclinical research is trained to people who are going to be doing it, because people do not know how to design studies. You know, he says, I ask people, how many mice did you use for your study? And they say, oh, 6. And he said, why did you use 6? And he says, well, everybody uses 6. It's like, that's not the way you design an experiment. And so he's trying to rethink how to make medical education work at Johns Hopkins. And I think he's getting some traction there. Carolyn Compton is a pathologist at Arizona State University, was a senior official at the NIH, and she thinks that, you know, she sees ways that pathology can improve, that tissue is gathered fairly haphazardly and stored in these paraffin blocks and so on, and then it's used for purposes that are you know, are sort of the fundamental basis of precision medicine. And she says, we don't pay close attention to how this data, how the tissue is harvested, how it's analyzed, how it's handled, and we don't know really how much those materials change through this process. And so what we're getting, you know, her philosophy is, if it's garbage in, we're getting garbage out on this. So she's been pushing really hard in the world of pathology to say, come on, people, let's standardize these practices, let's do it. So I talk about her story as well. Another person is Brian Nosek, who is thinking a lot about transparency and so on. Obviously, there's a lot more to be said about that. But one of the favorite stories I have of Brian Nosek was when he was at the University of Virginia up for promotion. They said, show us your, you know, give us all the papers you've published. He said, I'm in social psychology. We publish a lot. I've got like 100 papers. And they said, give us all 100 of your papers. And he said, what are you going to do? 100 papers? You're not going to read 100 papers. What are you going to do? Weigh them? And they said, that's the way we do it. Bring us your 100 papers. So he did, and happily he got promoted. But he tells this story that, you know, if he had been told when he got his job initially, you know, in 3 years when you're up for promotion, bring us your 3 best studies, and we'll evaluate you based on that. He said, think how differently I would have constructed my research career. I would have thought a lot differently about not just getting a huge volume of papers, but thinking about what are the strongest and best ideas I have, and bring them forward and emphasize that. And that gets to the incentives that I think are misaligned right now in biomedical research. And I think it's, you know, people like Brian are thinking about how do we change the incentives, how do we improve the sort of the culture of science to make it work better. And Barbara Schlussers at Johns Hopkins is sort of decided, she's not the only one, but she's one of these folks who are at universities around the US and perhaps elsewhere in the world who are saying, if the researchers at our institution come up with something that seems like a possible drug, before they publish it and make a big deal of it, and then try to market it to drug companies to get a spin-off, bring it to a special lab that they've set up, and they will try to reproduce the result themselves and make sure that they're valid results before they put them out. She said, the last thing I want is to have more people from Amgen like Glenn Begley coming back and saying, yet another failed academic research project. So she's been sort of doing this screening as a way of thinking, you know, let's build in a little bit more checks and balances into this whole system. And she says that, you know, I asked her what proportion of results out of Hopkins did she find her valid? She said, well, maybe about half. So, I mean, even at some of the top institutions in the country, and with great care to reproduce them, there's not a fabulous track record. But the point is, there are ways the system can think about these problems and try to sort of self-correct. And so again, I talk about these positive things that are going on as a way of reminding people that it's not just all about you know, fail, 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 but there are people who are thinking, somewhat self-appointed sometimes, how to do it. And I did have a picture of John, but since John and Steve but I thought since he's here, I wouldn't bother to flash him on the screen. But at any rate, you can ask him questions directly. And so, anyhow, I'd be happy to take questions, I guess, after the break. So thanks for your attention.